So I think we can take the question of transversal lines in a few ways. One of the questions it seems children asked is, but where are there transversal lines in life? Which is interesting for me because that's what we see all the time. So of course then they have buildings and you have neatly stacked things and you have a photograph that you want to be aligned with the wall perfectly. I mean there may be times when you get something that is 90 degrees or perfectly horizontal or otherwise, but generally you are going to have if you have a roof, no? How are children drawing a house? They are always drawing a house like this? I don't think so, right? When they draw a house, they will always draw a house like that. When they draw mountains, what are they drawing exactly? Like this? That looks like a skyline of Manhattan. No, that's not how you draw mountains, right? So generally, children will draw mountains like this and even put a sun in the middle or something, right? So this is the most often drawn picture. Very sadly. But anyway, that's not what mountains and sun really looks like. But anyway, but these are things that we see all the time. So forget about everything. I mean, there's a desk. If I draw something, I'm looking at it from here and there's a chair. Very good, 90 degrees in the desk and the chair. Now let's put a child on it. How do you think the child is sitting? Exactly at 90 degrees? No, the child will always be sitting at an angle. In fact, we have to keep saying, make your back straight, make your back straight, make your back straight. Otherwise, how will the child be sitting? Hopefully, the child is sitting like this and not sitting like this. Which means sleeping on the desk, right? That's all you want. So, I mean, yes, there are transversal lines all around us. Yeah. And when you are holding your hand, if you're standing, yeah, it's very unlikely that people stand, like this all the time. This is how you stand with your legs and hands. No, not possible. By the time you do that split, you will get a pain. Unless you are really, really trained, you can't even do like that, right? So we have angles everywhere. So I think maybe they're just having fun with you and asking when do we see transversal lines? We see transversal lines everywhere. But let's look at if there's a way of introducing it in a more creative way. Okay, and the way we are going to do that is by looking at actually angles. What's an angle? And we are going to use Indian knowledge systems. So we are going to use how angles were defined in India. So angles were always defined in terms of circles. Okay, so I have a circle, and if I travel a certain length in the circle, maybe I can use a different color for that. Is this color visible? Hard to say. Yeah, sort of visible. Okay. So, how much did I move in the circle used to be a ratio. It's a ratio of the thread that goes along from here to here, right? So that's arc. That's called an arc length. So it's an arc length. Yeah, divided by the radius. So this is the angle. But this is the angle in radian, right? So that's why it's called a radian. Radian times radius is length. So if you go all around, that's 2 pi. 2 pi times r is 2 pi r. That's the perimeter. Yeah. So radian, this is the angle in radian, in which the full angle is not 360 degrees. It's not degrees. This is the same as 2 pi. That's in radians. So it's in radian. So you can do actually an exercise in which you draw many concentric circles, as we had done in the school. We draw many different concentric circles, and we ask, okay, I'm going to draw for this length. What was the radius? I'm going to put it along the circle and find where it will be. And what you will find is, if you have circles of many different radius, one line will go through all of them. Okay, so that's 1 radian, by the way, because a ratio is 1, arc length is 1. So that's called 1 radian. Most people don't know what 1 radian is. They'll start calculating 362 by 2 pi and so on. So the angle that we are talking about, which is 1 radian, is simply you take the radius and then you take this radius and you put it along the circle where it will come. So you mark all these points for different circles and then you join all of them. That will give you a transversal line. And that's a transversal line in which you now understand what is an angle. An angle is arc length divided by radius. So you just keep repeating that. And then you discover a transversal line. You don't introduce a transversal line.